22nd, 2011, we switched lessons. We're actually going to do lesson 5.3 today, so it's on page 228 in your text and your blue notebook. You guys are supposed to copy down these two major bullets. We're going to do example number 2, A. We're going to start with 2A. So, question says 6x plus 3. What we're doing today is the opposite of what we've been doing. We've been doing expanding and then simplifying. Okay? This is called factoring. We're just doing common factoring today. So make sure you have that title down in your blue notebook when you're taking notes. Okay? So, factoring. I need to find the common factor, and not just any common factor, the greatest common factor. So some of you will be able to look at something like this and do it in your head. What we're going to do is we're going to actually go back to grade, I think, 4, and we're going to write out all the factors of numbers and circle greatest common factor. If you can do it in your head, amazing. Do it like that, okay? Nice and fast. The more you do this, the easier it's going to get. This is one of those things in math you need to practice. So, here's our number, equals 6x plus 3. I need to find the greatest common factor. So I have 6x, and I have 3. Now I'm going to separate 6x. I'm just going to separate it into a 6 and an x. So we have 6, and we have an x. Now, because there's no variable or x attached to this 3, we don't have to worry about the x right now, okay? So I don't need to find any factors of x. And I'll show you how to find factors of x later. So the only factors I need to work with are 3 and 6. You know what? We'll do them in a different color just so it can differentiate. So factors of 6, 1, 2, 3, and 6. Pretty easy. Factors of 3, 1 and 3. Common factors, 1, 1, 3, and 3. And our greatest common factor, you guys remember GCF? Greatest common factor is 3. So, now that I've found my greatest common factor, I need to, I'm going to show you the technical term and then a shortcut to do it. You're technically going to divide both of these terms by our greatest common factor. So I'm going to divide 6x by 3. I'm going to divide 3 by 3. What's then going to happen is the number we divided by, our 3, so right here we divided by this 3, that 3 is going to come to the outside of a bracket. So we're going to have a bracket now. The number we divided by the 3, he's going to be outside of the bracket. Okay? And when we divide our two terms, whatever's left is going inside the bracket. So we have 6x divided by 3. Anyone know what it's going to be? 2x. So I'm left with 2x. And 3 divided by 3? Positive or negative? Positive. 1. That's it. I found the greatest common factor. So my final answer here, my factored form of this is 3 bracket 2x plus 1. Okay? Now yesterday, remember we did distributive properties, stuff like that? Great. I can just distribute the 3 back in, and I'll end up with the same answer I started with. So that was simple enough. I'm going to show you another way to do this question. So same question, example 2A. But we're going to do what's called plus 3 prime factors. I don't know if you guys remember prime factors a couple of years later in school. Maybe grade 5 or 6 you would have started with these. Prime factors is that factoring tree, if you guys remember. So once again, 6x. Don't worry about the x right now. I'm just going to deal with 6 and 3. So I have the number 6 and the number 3. I need to find the factors of these numbers. Or, sorry, the prime factors. So the prime factors of 6, well, I can split 6 into 2 and 3. And then 2 is a prime number. The only factors of 2 are 1 in itself, so I can't break 2 down anymore. It's considered a prime factor. Okay? Same with 3. Only factors of 3 are 3 and 1. Can't break it down anymore. So we leave it at that. My other factor 3, it's already a prime factor. Can't break it down anymore. Okay? So, now that I've done this, 2 and 3, I'm going to rewrite this question in its prime form. And, sorry, with x, so I should do that in blue. Prime factors of x, well, the only factors of x are x times 1. I can't break it down anymore, so consider it a prime factor 2. So x is a prime number, 3 is a prime number, and 6 is broken into 2 and 3. So I'm going to rewrite this question. I'm going to rewrite 6 as 2 times 3. I'm going to rewrite x as x. I can't change it anymore. Plus, I'm going to rewrite 3 as 3. Can't change it anymore. Okay? All right, so I have that now. Now what I'm going to do is I'm going to take out common numbers that occur in both terms. So there's only one common number here. Does anyone know what it is? 3. 3 shows up here, and it shows up here. So, same idea as above. I'm going to take that 3. I'm going to put it outside of a bracket. So the 3 now goes to the outside of a bracket. And whatever is left, I just write in the bracket. So I have 2x, 2 and x. And because I took 3 out, what would be left? Has to be a number. 1 plus 1. And if you notice, we got the exact same answer as we did above. So take a second, take this in. Okay, so question 2b, we have the question 8x squared minus 7x. Okay? I'm going to do this 2 ways. I'm going to do it the greatest common factor and prime factoring. So I'm going to write it twice. Greatest common factor, so we're going to do it in red. That'll be our greatest common factor way. Okay? And prime factoring will be in blue. 8x squared minus 7x. So we'll call this the prime way. And GCF. GCF, greatest common factor. Okay, so I'll do GCF first. Greatest common factor. Now, because I have an x in both, that's one of the things you need to recognize. I'm going to actually have to find the greatest common factors of x squared and x also. Okay? Consider them a group, and consider the coefficients a group. So, I have 7 and 8. I need to find greatest common factors of 7 and 8, and I said that backwards. There you go. And that's one pair of numbers I have to find. The other set of common factors I have to find are of x squared and x. Okay? So consider these a grouping and this a grouping. Always group the coefficients together and the variables together when you do greatest common factor. So factors of 8, we got 1, 2, 4, and 8, and factors of 7, 1, and 7. Well, when I look through this, the only common factor here is 1. Kind of screwed that one up, but only common factor is 1. If I take out 1, is it going to change anything? Are those numbers going to change when I divide them by 1? No. Nothing's going to change. So, like, there is no greatest common factor. Well, there is 1, but it doesn't change anything. So I'm not going to take 1 out, because when I redistribute 1, it doesn't change anything. It's irrelevant. But let's do factors of x squared and x. What are the factors of x squared? Anyone know? Yeah. X times x. That's a factor. So I can do x times x. Or I can do what? Anyone know another one? X squared times? X squared times 1. Those are another 2 factors. So x times x, or I don't have to rewrite it. Think of this like if I was looking at factors of 16, 4 and 4. I only need to write the 4 ones, right? So I write x ones, because I know x times x will give me that. And I can do 1 times x squared. Those are all the factors of x squared. What are the factors of x? X times 1. Okay. So we have x and 1. Now, I want you to just recognize that in this case, we don't actually know if x is greater than 1 or less than 1, but let's assume it's a greater common factor, okay? Because there's technically 2 common factors here, 1, and 1 will always be a common factor, because you can multiply everything times 1. So almost consider it irrelevant. If you have 1, you can't really take 1 out. It's not going to change anything, okay? But I can take x out, and x is a common factor. In fact, we'll call it our greatest common factor. So what I'm going to do here is I'm going to divide this one by x and this one by x. So my next line, I'm going to have my x outside of the brackets, and inside the brackets are what the answers would be when I divide it. So what would 8x squared divided by x be? Whoa. 8x. Okay? Try to remember your exponent rules. This is going to be 8x. Yeah, the x's cancel out because there was, think of it as if there were two of them there, and there's only one on the bottom. What about here? What's this going to be left? Negative 7. That's it. I factored that now, okay? I've taken out an x from both. That was our greatest common factor. I'm going to show you the prime way. Personally, I think the prime factoring is a little easier, but... Question? Go ahead, Tom. Okay, same idea of prime factoring. Take the primes of 8. Actually, sorry, I have 8x and 7x. So, I need to find the primes of 8, primes of 7, primes of x, and the primes of x squared. I need to find the primes of all of these. Think about separating them, okay? So, 8 can be broken down into 2 and 4, and 4 can be broken down later into 2 and 2. So I'm going to end up replacing 8 with 2, 2, and 2. Okay? I know it's tough if you haven't done prime factoring in a while. Think of prime numbers as if you multiply them all together, you'll end up with your original number. So I can't break 2 down anymore, but I could break 4 down. It goes into 2 more 2's. So I'm left with 3 2's. 2 times 2 times 2 is 8. Okay? So I've just broken this down into a basic form of the number. 7. Can I break 7 down? No, it's just 7. What about x? Can I break x down? No, it's just x. Can I break x squared down? What? XX. There you go. X and x. So, now that we have our numbers, we're going to replace them. I'm going to replace 8, like I said, with 2 times 2 times 2. I'm going to replace x squared with x and x. And I'm going to replace 7 with 7 and x with x. Sorry, this is a little crammed, I can tell. Okay? Can you guys see this? I know it's a little crammed. So now, take out all the common numbers. If I look at our numbers, or our whole numbers, 2, 2, 2, and a 7 in the other one, none of those are common. So I can't take anything out there. What about here? Can I take something else out? I can take out one set of x's, right? Here's an x, and here's an x. Is there another x to take out? I really need to separate this. I realize this is getting a little crammed, okay? Think of that as some side work we did, okay? Anything else I can take out of there? Is there a 2 in both? No. No, that's it. I can only take an x out. So, my next line, remember I'm doing this in blue. I took an x out, it's on the outside, and in the brackets, what am I left with? Well, I'm left with 2, 2, 2, and an x. And in my other number, what am I left with? Just 7. Okay? Well, now that I've done all this, I just need to simplify that again. Okay? So when I simplify this again, what is 2 times 2 times 2? 8, and then times x is 8x. And I can't really simplify 7. I found the exact same answer. X bracket 8x minus 7. X bracket 8x minus 7.